I've seen some of the research that came out of that as a result of Tim doing some awesome blog posts where we continued up the volume shadow copy research, where we talked about grabbing, the NTS-DIT from the shadow copies and extracting hashes, and that's pretty much become the standard way that we've done that. Some of the original research on that, what we talked about was, just hiding stuff in volume shadow copies and lurking. So the idea being, you can create a directory, and this presentation may go really bad because it's almost all live demos. All right, so I can create a directory called malware. All right, malware, and in there I can put create a backdoor, whatever it is that I want to hide in the operating system. Right, I can just
window about 5% to the right.
How about like
not larger?
No, it's just
move it. Make it zoom it back out and move it a little bit to the right. That's all.
All right. Is it cutting off the right side of my screen there?
Yes, it is. There you go. Perfect.
Okay.
Thank you.
All right, so I can create a backdoor directory, just put my malware onto the system. Then we create a volume shadow copy. Once that information is in the volume shadow copy, then of course I can delete the backdoors. You can overwrite that backdoor on the hard drive with ones and zeros so that it's gone. You can wait a couple of weeks. You can come back months later. You can cd ... You can rmdir the malware off the system, and then you can still execute the code directly from the volume shadow copies. So I can cscript vss own execute malware / backdoor. This will go through all the volume shadow copies that exist, find that malware that's on there, and of course pop it up. Now this copy of backdoor was just a copy of putty, so this is going through and finding the information in the volume shadow copies, and I'm still able to execute it. So even after information has been deleted off the systems, it can still be executed off the hard drive. This is a great place for you to hide because systems administrators aren't looking through their volume shadow copies to see what's being kept there. Most people aren't even aware that it's there. Some additional research that was somewhat related was hidden alternate data streams, and this one I got to give most of the props to Matt Graber on this one, but I did a post on paul.com some time ago about creating some files that had reserved word names. So at the DOS prompt you have com and lpt1 and aux and other reserved words that you aren't supposed to be able to make file names that have those reserved word names, because copy some file to lpt1 is supposed to copy that to your printer and result in that thing being printed. So lpt1 is a reserved word name. You're not supposed to be able to create files with that name, but if you use this little syntax, you can make files. I can copy my temp. I'm going to copy my putty, which is just put on my machine, right? And I'm going to copy that to whack $whack c:\\. Let me actually do that in this other window. Let's see. I don't have another window. Let me cd into mark demo, and then I'm going to copy /temp /putty, and I'm going to put that into whack c:\. mark demo aux. Right? So now aux is a copy of putty. Okay. The interesting thing about aux is that it's not easily deleted. So once a machine has that file name, if you try and delete it, right, it tells you that you can't delete that because it has a reserved word name. If you try and go through Explorer, mark demo, and delete it, it'll give you a nasty error message when you try and delete it. It'll say, or delete. Yes, I'd like to delete that. It says, sorry, aux is too large for the destination file system, and it won't allow you to delete these reserved word names. So I thought that was pretty cool. I could put malware on a system, and then the people who own the system can't delete that file from that file system unless they use that special syntax, right, which was del whack, put the whack $whack, and then you can put mark demo, put the full path to it, and you can delete the file. Okay. Well, Matt Graber figured out that, hey, not only do these reserved word names, are they difficult to delete, but if you put alternate data streams on them, right, then those are completely invisible to dir/r. So here you got file with ads.txt is a file that has an alternate data stream attached to it, and if I do dir/r, which is what we use to see the alternate data streams that are attached to files, you can see that the alternate data stream that is on file with ads.txt comes up. We can see that with dir/r, but LPT1, you can't see any alternate data streams that are attached to it. But of course, there actually is one. Let's see if I go to Notepad, /wax/mark demo /lpt1:ads.txt. It'll bring up an alternate data stream that's been attached to that. You just can't see it with dir/r. Now again, if you want to be able to see these files that are hidden on there, you can do dir/r, give it the full path with the /wax at the beginning, and then the alternate data stream does show up attached to LPT1, but by default, dir/r isn't going to show you those. Okay? So that's some other related research. I did a post on paul.com with sidejacking SSL cookies, which I think is so cool. So you need to do key logging. You want to capture usernames and passwords off of a remote target, but you don't want to introduce malware to them. There is a service that's built into Windows called event tracing, event tracing for Windows. And there are service providers that, you guys know that in the event logs, you can go in, you can see the security events, the application events, and whatever the other events, system events that you have on the system, right? You can enable other providers that will log other things. Okay? Among those providers are things that will record all the packets that go in and out of the machine. There's also a provider that will capture all of the information that's being transmitted through Internet Explorer, including SSL encrypted websites. So even if the website is encrypted, you can still capture usernames, passwords, cookies, and other information that's being transmitted back and forth. I had a penetration test that I was on. I gained access to CFO's machine. He was already authenticated to a portal that I needed to get access to. It was an SAP portal on the inside of the network. I really needed that session cookie that was inside of his browser. I didn't want to force him to log off, try and capture that. Just enabled event tracing for Windows, turned on the appropriate logging provider, captured those information. And again, that's out there on paul.com. You can read about that one on paul.com by just Googling sidejacking SSL cookies with ETW. The other thing is, I tweeted this when I knew Larry was going to be doing the cyber challenge in DC with some people, and I thought this would be a kind of a cool way that you can hide things. And you can actually crash Explorer with this, which I think is always fun, right? So let's see. On Linux, people have been creating these space directories or a dot space directory for a long time in order to hide their information on the system, right? So it's difficult to create a dot space directory on Windows. If you just say make dir, dot space, well, Windows doesn't like that. Okay? It won't let you create a dot space directory. But again, using that same syntax that we used before, I can do something like this. I can say make dir /wax /mark demo /quote /space / and I could create a dot space / directory, which would blend in if I did the dir/r. If I go a little bit further than that and I add another / space quote directory, all right, it tells me that I've already created that one in preparation for this demo. And that there you will see there's a / directory in there. If I do a dir/s on this, you'll see that there actually is something in my dot space / dot space directory. That's a copy of PuTTY that I placed there. So the question is, okay, I can create these dot space directories. How would a user then get into that? If they were just at the command prompt and they were trying to get into that directory, it's difficult, right? So if you try and cd dot space, well, that's going to take you back a directory, right? cd mark demo cd quote dot space / close quote, that doesn't take you in there. The only way that I know of to get in there was actually shown to me by a student very recently. If you do a dir, what is it, /x, does that show you your 8.3? These file names come up with these odd little 8.3 names. I don't know what 45AA1 is or where that's coming from. I think that's those aren't random hex values, right? But I think they might be being pulled off the stack as it's generating these odd file names. But you can cd into that directory from the command line by changing into the 8.3 and then the 8.3 of the other one. But that's the only way that I know of to actually get into that directory. If you try and go into it from Explorer, mark demo. All right, so I've got my dot space directory here. I'm going to double click on it. Okay, well, I went into my dot space directory. What should I have seen there? A dot space, right? I should have seen a dot space, and in that dot space was a PuTTY. But when I went into dot space, and clearly the path says you went into dot dot space, but I'm still in the exact same directory that I was in. So what happens if I go into dot dot space again? Oh, okay, now you're in dot dot space, but the path dot dot space dot. Okay, so if I go into here, I should see putty, right? Yeah, sorry. Mark demo dot dot space dot dot space dot space refers to a location that doesn't exist on your hard drive. Yeah, duh, it doesn't exist on my hard drive. That's not a path that was created. So what kind of error is this known as? It's a path canonicalization. It's a path canonicalization error. And where have you seen a path canonicalization error before? The greatest exploit of all times, right? MS08067 was a SMB-based net API path canonicalization error. Is this exploitable? I don't know. If it is, it's not exploitable by me. I can tell you that. Or this would be a whole different talk. Okay. All right. So that's some of the stuff that that I've kind of done over the last couple of years in leading up to this. So I've been doing a lot of researches in living off the land, right? Implementing tools, rootkits, way that we can hide in the system without adding new malware to it. I think if you put all these together with the new stuff that I'm going to introduce to you today, I think we can pretty much safely say that you can own Windows straight out of the box without adding any malware. Okay. The new stuff is a really ugly bug, right? And it's built right into Windows. But here's the thing: is Microsoft would say it's not a bug, it's a feature. Okay.
Very cute.
Thank you. So let's talk about what happens when you take an exe and you load up DLLs that are associated with it, because this ultimately becomes implementing a full user mode rootkit using just built-in Windows tools. Okay. So if I have an executable such as Explorer and it needs to be able to read files from the disk, right? It's going to have an import address table that is going to say, I need to pull in these functions from these DLLs. It's going to call load library A, which is going to go out and grab that DLL, load it into the memory of my executable, and populate the address that's in the address import address table with a pointer that points down to the actual address in memory where the DLL exists. Now, kernel 32 may not actually contain that function either. In reality, kernel 32 doesn't interact directly with the kernel at all. It always imports things from another DLL, right? A net DLL, ntdll.dll. So it's going to have an import address table as well. It's going to call load library A, and it's going to have a second pointer that's going to go to ntdll.dll. Now, when things need to get down from user mode to kernel mode, they're going to put things into the EAX register, and they're going to call sysenter. And then your NT executive is going to see the function call you're trying to make, look up in the system descriptor table, see what you're trying to execute, and then go call that function that actually exists in the kernel. And this is how code is executed. So with user mode rootkits, it takes advantage of these linkings between functions, and you're going to insert new DLLs into memory of a running process, and you're going to change the pointers that are inside those import address tables to say, hey, look, if you want to call find next file, don't go down here. Instead, I want you to go over here to my rootkits DLL, where I've exported that function, and then you're going to call the actual DLL, and then based upon whether or not you want to filter the responses going into the rootkit or take the response that comes back, you're going to change the information that the user can see, right? This is how user mode rootkits work, right? We're all familiar with that. This is how Microsoft illustrates it, right? They say, all right, you've got an application that's talking directly to Windows, and then afterwards, what you do is you'd have an application that, instead of talking directly to Windows, it talks to a shim, which then talks to Windows, okay? Microsoft understands how user mode rootkits work. There's only one problem, and this slide is not from, this is how user mode rootkits work. This slide is from, this is how Microsoft's application compatibility toolkit works.
Yeah.
Okay, so what is the application compatibility toolkit? The application compatibility toolkit is a tool that's designed to take old, horrible programs that are horribly written and make them work on new, modern operating systems. Okay, so I write a program that goes to read user profiles, and it goes onto my hard drive to /documents and settings. It's hard-coded in my executable to go to /documents and settings to grab copies of user profiles. Then I bring it on to Windows 7. Where are the user profiles on Windows 7?
Under users.
Under users. So this application no longer works. So we can go back to the developer and say you have to rewrite your program so that it will, use an environment variable to figure out where the user profiles are, or we can just fix it with a toolkit such as the application compatibility toolkit. So what we would do with the application compatibility toolkit is we would create a shim that says, application, I know that you asked for // documents and settings, but let me show you a copy of what's in the users directory instead. So you asked for this, I'm going to show you this. You have a program that's trying to access registry keys that are written for old versions of the operating system, and instead you're going to have the operating system lie to that application and say, I know that you're asking for this copy of this registry key, but instead let me show you this copy of the registry key. Does this sound like a good idea? Excellent idea. It is an excellent idea. All right, so this is what goes into the application compatibility toolkit. We got the application compatibility toolkit admin. We've got shims. Shims are just SDB files. They're configuration files that we create on, say, an attacker's machine, and then we're going to move to a target machine. Okay. The shims are made up of application fix-ups, which are tweaks that we're going to make to registries, to DLLs, to the way things load, the way the program operates. You can take multiple fixes, you can group them together into what's called a compatibility mode, right? So multiple shims, or multiple fixes into a compatibility mode. What's really nice about these compatibility modes is if you apply a compatibility mode to an executable, then it affects the executable and all of the child processes of the executable. Okay? And the only thing that you really need on the target workstations is SDB inst, which is an executable that is already installed by default on all Windows systems. So on my machine, I use the application compatibility administrator. I create a shim, a little .sdb file. I then move that to a target system. I install it by saying SDB inst, give it the name of my shim, and then whatever patches or fix-ups I've done inside of that shim are then applied to the executable. Okay? So this is the functionality you would commonly see in rootkits, right? I might do process execution redirection or API hooking or hiding from the file system in the registries or disable security features in the operating system or just create new backdoors. This is what we can do with the application compatibility rootkit, or the application compatibility rootkit. Yes. Okay. All right. So let's just go through and do some examples. So first thing I'm going to do is let's use the application compatibility toolkit to hide malware from a incident responder by remapping registry keys. Okay. So we'll run a copy of regedit here. Okay. And where do I go to find the malware that is automatically set to start up on my system? HKey local machine, software, Microsoft, Windows, current version, run. Yep. All right, so here's my current version run key, and you can see that I've got what? Adobe ARM, Groove Monitor, right? MSC, VMware Tools, and VMware User Processes all in my registry key. Okay. So I've got a little shim here that I've created. Let's go ahead and open the shim and see what's in there. I'm going to open up this shim that I've created called hide run from regedit. You can see here I've got multiple databases. You can't see. Move this stuff a little bit to the right. Okay. All right, you can see multiple databases here. I'm going into this hide run from regedit database. I'm going to go, I've got one fix-up in there, and that fix-up is here. I'm going to right-click, I'm going to say edit the application fix-up. First thing you do is you give it the name of the fix-up. You tell it the name of the program that you're going to fix. So I'm fixing up regedit. Let's say next. This is where you would select a application compatibility mode. Again, compatibility modes are groups of fix-ups. Okay. I'm not going to choose any of those. I'm going to go in here, and you can see that I have 811 different things that I could do to the operating or to this application to modify its behavior. Some of these are tied specifically to specific applications that Microsoft has got fixed. There's some pretty interesting ones in here. Let's see, I like that one right there in the middle, right, or on the top of my screen there. It's got the blue pill application compatibility fix-up. That's interesting. There's also one in there for red pill.
For your hard drive?
It's going to modify the behavior of an application. Okay, there are things in here such as virtual registry editors. I'm just going to show the ones that I've got selected. You can see in this case that I've selected, there's one called virtual registry. And if I come up and I look at the parameters for this, you can see that I have basically remapped the run key to the run hidden key in this state. Okay, so in this case, I've created another registry key that's right below run called run hidden. Now, what an attacker would most likely do is not redirect this to run hidden. They'd instead create a volume or a registry key that's down in H key class's root somewhere deep in the operating system where you're never going to find it. But you know, I'm keeping it simple here, right? All right, so I'm going to install this shim by saying sdb-inst hide run. Let's go into the correct directory, cd into Windows, app compat. Then I'm going to sdb-inst hide run from regedit. Okay, and then I'll run regedit again. Go out to my run key. You can see that my run key now only has Adobe and not malware in it. Okay, which is pointing down here to the run directory. All right, so that's interesting. I can hide from incident responders using the application compatibility rootkit. All right, let me go ahead and uninstall this because otherwise I will. So it's installed. Can't see it from regedit, but what does the operating system see? Well, the operating system still sees the regular. So if I do a reg query, query, h key local machine software, Microsoft. Thank you. I'm glad you're here. Microsoft, Windows, current version /run. You know, all the registry keys are still there. So the operating system still sees the original registry keys, still boots up. It behaves normally. The only thing that I've hidden it from in this case is regedit.exe. Okay. All right. sdb-inst/u hide temp from regedit. Hide run from regedit. And it's uninstalled. So registry keys will be back. Another thing I can do, I can remap directory key or directories on the hard drive, CLS. All right, so let's see. What are incident responders going to use to find information on the hard drive? Well, they're probably going to use cmd.exe. They're probably going to use explorer.exe. Let's remap some hard drives. So here I have another application compatibility toolkit shim called let's see, hide temp from cmd.exe. Okay, if I open up hide temp from hide temp, let's see, where did that just go? File, open. Okay, I'm going to open up hide temp from cmd.exe, and let's see. Oh, thank you. Okay, thank you. Select this one, and then let's see. Right click, edit my fix, go in there. Okay, I can see that this one has something called correct file paths. And with correct file paths, you just simply give it an old directory name and a new directory name. So what happens when I apply this? sdb-inst hide temp from cmd.exe. But well, first let's look in this directory what's in my temp directory. Now you can see that I have a lot of garbage in my temp directory, including botnet and other things. Now let's start a new command prompt, okay, and I'll do a dir on my temp directory. And you can see that my temp directory is basically empty in that particular command prompt. Okay? So a couple of interesting caveats when you're using this, and I'll get to those here. All right. So these are just slides going over what we just did. Okay. If you're going to shim anything that's in the system32 directory, such as cmd.exe, explorer.exe, or any of the other executables that are part of the operating system, Microsoft is going to exclude those by default. Okay. So you would have to basically manually include those inside of the application compatibility toolkit manager. When you're in these fix-ups, if you look in the parameters here, it's got this include section. You can see that I've had to manually include cmd.exe and all associated DLLs because those are excluded by default. Okay, that's one option. The other thing you can do is when you launch application compatibility toolkit, but actually you could you saw that I had 811 different fix-ups that were available to me on inside here. By default, there's only 360 that you will see if you launch the application compatibility toolkit administrator. But when you run it, you add the /x option, which is an undocumented application, but obviously we can look at it by simply pulling this thing up in IDA. You'll see that there's a /x option. With /x, it shows you 811 different fix-ups, including blue pill, red pill, and other interesting ones. It also will automatically include all the executables and DLLs that are in System 32 and not exclude those from your shims. So you can create shims that will shim the operating system itself. Okay. Additionally, if we take sets of shims and we then group them together into a compatibility mode, I can apply that to an executable, and then its child processes will also be affected. So I can create a shim or a group of shims that hide directories from Explorer, and then anything that Explorer launches will also not be able to see those registry keys or directories. Okay, hiding directories and registry keys is interesting, and that could be useful to us as penetration testers in hiding from, I don't know, antivirus products or other products that are trying to look into the directories where we're going to be keeping our stuff. But really, I haven't come up with a whole lot of options for how I could actually use this in a legitimate penetration test. This is really more of a talk to say, hey, this is an interesting thing that I think we could see attackers, malicious attackers, actually using in environments. And since doing this talk at B-Sides, Augusta, Georgia, a couple of weeks ago, I've actually had a couple of people that have contacted me and said that they've seen malware that is actually using some of the techniques that we're going to be talking about here. Yes, sir, you have a question?
Is there a way to see which compatibility kits are actually actively running?
The question is there a way to see which application compatibility toolkits are actually running? Yes, sir, and I'm going to get to that in just a second. Okay?
Thank you.
All right. Yes, sir. The question is, do you need to have administrative rights to install the shims? Absolutely. You have to be an administrator to install these shims. So it's not pre-exploitation mode, but it is definitely, once you gain access, you can make these modifications.
With the application virtualization, do you know if AV tools can see that and if they can actually delete and remove the files?
Yep. So the question was, with the path canonicalization error, can AV tools still parse down into those directories? And I have found that most applications that are using the standard find next files APIs are able to successfully get down into those file structures and see them. And when I did a dir/s, you could get to them. Python can get into these. Just about every application that I've written to parse directory structures gets past that. Why it crashes Explorer and you can't get to it from the command prompt, I don't know. Okay, excellent questions. Okay. All right, so make sure you include those modules. Other interesting things that you'll see people doing. Yes, sir.
So if you use CMD.exe on the CD that you're using for incident response, does it still hide that if you do it on the path thing or actually file it?
Yep. So the question is, I have a known good CMD.exe off of a CD, right? Is it going to shim that? It shims it based upon an executable name, but you can also define additional criteria beyond just a executable name, like you can include the path and things like that. An attacker would want their filtering process to be as generic as possible, and the most generic they can get to is just a file name. So if I rename cmd.exe cmd2.exe, then the shim does not apply to that file name. Okay? Other things attackers can do, they can inject DLLs into executables. So if you want to include a copy of Meterpreter inside of Explorer or cmd.exe or anytime it's automatically running, this will automatically load Meterpreter in there and launch the payload. Because the payload is included in main DLL, it's going to automatically be launched as part of the load in this. So in order to do this, you just call the inject DLL application fix-up. Okay? You want to kill any executables, that nasty antivirus product, you don't want that running on the system. Okay? There's one called terminate exe. You just give it the name of an executable. That executable will never run as long as your application that you've marked up is running. Okay? Or if you want to prevent DLLs from loading, there is an ignore load library fix-up that we can use to say, all right, anytime Internet Explorer is running, I don't want the HIPS DLLs to be injected into the process. So if it tries to load the HIPS DLLs into the systems, then it will not be loaded into the systems. There's also other ways that you can mess with the loading of files. There's something called shim at EAT. So you can say, instead of marking up the import address tables of the executable, I want to mark up the export address tables of whatever DLLs I'm using as my target. So if you're having a process that isn't loading properly and your shims aren't working, you can mark up the export address tables on the DLLs as well. You can do things like disable security. Notice I have it in quotes, right? Because what this is doing, remember, is it's creating a virtual environment or a virtual world for your application to live in. So your application will think that there are no access control lists on the file system. In reality, what happens is the application toolkit manager will launch the program as an administrator. They will then have to select their UAC prompts or whatever so that it will launch. But once that is running as an administrator, then it'll bypass access control lists and things like that. You can, however, disable NX and ASLR and other security features that the processors will let you to disable. Okay. You can do process execution redirection. So you can redirect executable as a markup. So I can say anytime they try and launch cmd.exe, have them automatically launch this other process instead. Or you can do DLL hijacking. There is a load library from current working directory. So you don't want them to use the DLL that Microsoft wants to load with that application. Instead, you want them to, say, use an older version of that DLL. Put the DLL in the current working directory. Tell them to load that. Or you don't even have to do it from the current working directory. You can hard code what path it's going to look for DLLs. So if an executable was hard coded to grab things out of System 32, or it wasn't hard coded, then you've got standard path injection, right? You can say, now load these DLLs from this directory, right? So we all love MS-08067, right? Who doesn't love MS-08? We just had the cake here last year, MS-08067. Do you guys miss the days when every computer on the network was vulnerable to MS-08067 and your pen test was just pop the box, right? Well, this isn't an initial attack vector, but you know what? You can make machines backwards compatible with MS-08067. This is what the application compatibility toolkit does, right? It says take this application and make it backwards compatible with this stuff. So just take the DLLs that are unpatched and tell the workstation services that no, you're not using that version of the DLL. You are using this version of the DLL, which is going to leave it vulnerable to attack. So yes, there's something special about scanning a Windows 2012 server and seeing that it's MS-08067 vulnerable to attack, right? Or if you don't like the way that the application compatibility toolkit is behaving, right? You want to extend the capabilities that are in there, then you could potentially mark up the application compatibility toolkit itself. So shim the application compatibility toolkit and modify its behavior. There's 4 DLLs that are inside of, it's not the app compat directory. Let me see what, I don't remember what the directory is off the top of my head. It is, let's see, cd app patch. In the app patch directory, there's actually 5 DLLs in here. Before these do the bulk of the work. You can see the AC general, AC layers. Layers is associated with the compatibility modes. All of these other DLLs that are in this directory actually have all of the API hooking and everything that's associated with this. Now, of course, this directory is protected by Windows file protection, right? But there's the possibility that you could play some magic with changing the way the application compatibility toolkit is loading these DLLs and get something else done. Okay? I haven't done a whole lot with that, but it would be an interesting area of research to continue from here. Okay? So how do you prevent this from happening, right? How do you know if somebody is shimming your systems and using this against you? Well, first thing you need to do is make sure that people aren't getting on your box with administrative access, because you do have to have administrative access to install these shims. So don't let people get on your boxes with admin access to begin with, right? You can disable application compatibility toolkit support inside of Active Directory. There is under computer configurations, Windows components, application compatibility. There's a setting where you can go in and disable this. So I would suggest disable it everywhere that you know you don't need it, right? Or that you don't know that you do need it. Right? If you don't have old applications that need to be marked up, then try disabling this service, and then only enable it on those machines that you know you're running older versions of software. Okay. Now the shims do appear in add remove programs. Okay, so after it's installed, you will see that hide temp from cmd.exe appears here in my add remove programs. Of course, the icon is the same as the Microsoft.NET framework. So if I called this Microsoft.NET framework for something else you don't know what it is, then it would just blend in with the rest of the patches that you have installed on your system, with the exception that it's not going to be signed by Microsoft or is it, right? So they do show up in add remove programs, unless you shim add remove programs. Other possible applications. So application compatibility toolkit hardened honeypots. You can do all kinds of messing with people and making the operating system really confusing, right? When they go to the Windows directory, you show them the root of the file system, right? And they just get into this recursive loop of CDing in. They're not in there, it's CDing in there. Create application compatibility toolkits that make the system all but completely unusable, okay? Creating shims for every application that you suspect that someone might see. They try to run a copy of who is, send them over to some fake other application that will tell them that they're an administrator, or elevate the processes that they're in so that they are an administrator, and then watch what they're doing while they're in there. You can then create these really complex shims that make the system all but unusable. When you're not on the system, right, then you just do a sdb-inst and install your shim while you're away. When you come up to the system and you want to use the system and actually be able to access things in the system, you can just uninstall your shim. It goes back to normal operations and it'll work for it. Like my son came up with this idea as I was thinking, there's just no way you can use this like legitimately as a defender. I don't know what the purpose of this toolkit is. Well, I guess you can make old applications compatible with the operating system, but that doesn't sound like fun, right? Mandiant also has an application compatibility toolkit cache parser. So if you suspect that someone is using this type of attack against you, there is an application compatibility cache parser that you can download. It is available at the URL you see here, and I'd like to thank Philip Planamura from Mandiant for telling me about that particular toolkit. Okay. This research is really kind of new, and there's not much out there on this at all. Right. So there is one website that has got some information on the application compatibility toolkit. It's an awesome reference, and I used it extensively in trying to figure out how this thing works. And it's here. It's called The Secrets of the Application Compatibility Toolkit. The focus was on reverse engineering the DLLs and trying to figure out what exactly is this thing and how does it work. Okay. There's not really much out there at all on how this thing can be used. Okay? Like I said, I have received a few emails from people telling me that they've seen malware using these techniques in order to hide themselves in the systems. I couldn't get any more information about them, like what were they doing? Were they hiding registry keys? Were they hiding file systems? Were they making the system exploitable so that they could get back into the system after they had owned it the first time? I just didn't get much more out of them than I've seen that being used. Okay, so it's a brand new field of research. There's a lot more that can be done with this. And I welcome you guys to jump into this, begin playing with it. As you come up with new and interesting ideas of ways you can use this, please drop me a note, let me know how it's going. And that is all I have for you guys. Are there any questions about this? Let me go over here first. I'll work my way back.
So you're doing a lot of DLL injection and stuff. Have you done any testing with EMET running on the system?
So the question was, you're doing some DLL injection. Have you done any testing with EMET? So I guess the question comes down to, is EMET before application compatibility toolkit, or is application compatibility toolkit before EMET? And I guess in either scenario, I mean, if you're before EMET, then you can mess with EMET, right? If you're after EMET, then you can undo whatever EMET did, right? So I don't know the answer of who goes first. That's on the list of things to check out, but that's a good question. Other questions? Do the changes survive a reboot? Absolutely. When you install a shim, it automatically reapplies after a reboot. Yep. Let me. Have I tried making an application incompatible with the application compatibility toolkit? I wouldn't know where to begin to do that. I would have to get the application incompatibility toolkit in order to build such a tool, which I'm not even sure how I would begin to do that. You could maybe hide access to the DLLs, the app-compat DLLs that are in the Windows system to perhaps prevent applications from being able to get to those. That's a very interesting I'd like to play with that actually. Yes, sir.
You mentioned Explore.exe going in there. That's cool. How early in the process have you been able to get these things to apply? I mean, it's post SMSS, I'm sure.
Yep.
But somewhere between SMSS and Explorer, you know when this applies and how early you can get it?
Yeah. So the question was, you mentioned patching up Explorer.exe in the boot process from SMS.exe to CSRS.exe to user init. How early in the process can you get it? And I haven't gone back further than Explorer. However, it's just part of the standard executable load process. So anything that's using the standard executable load processes, and it's a user mode process, you should be able to shim. I haven't gone back any further than Explorer.exe. It would be fun to play with. Yes. Other questions? Yes, sir. Right? Yeah, so how does this relate to application compatibility mode? Like if you right click on an application, you go into its properties, you got different compatibility modes that show up there. The compatibility modes that you can create with the application compatibility toolkit will show up there after you've created them and installed them as shims. So this is, you're extending the capabilities that are built into there. So what happens if you disable it? Well, I would think that anything that you've got using those application compatibility modes would cease to work on those systems. Yep. Any other questions? All right. Thank you.
Mark, one question. Can that be turned off via the services?
Can it be turned off via the services? There is an application compatibility verification service that's on the system.